Hi, everybody, again. So we're moving on to 13.1. You guys know that. Chemical bonds and electrons here. Okay, we're also going to do 13.2 this week, but we do not do 13.3. You don't talk about molecules and carbon compounds, so don't worry about that. Okay. So big two terms here. First one, chemical bond. That's what we're focusing on today. Focusing on two types, not three types. I don't know why it says three. We're focusing on covalent bonds and ionic bonds. Okay, covalent bonds, all you really need to know is just understand what they are. That prefix co means to share, like co-workers, or means share together, like co-workers work together, cooperate. You're doing something together, right? It means together. So covalent bonds, they share their electrons. Their electrons are together with one another. Atoms share electrons. Chemical bonds are all about electrons. It's all about that transfer of electrons. This one needs electrons, this one has them. So here we go. We're going to make this work out. Covalent bonds are when we share those electrons. Here's my example of that. If I have two students sitting next to each other, and they have to be sitting next to each other or it doesn't really work. Let's say I have one student that has a pencil and another student that doesn't have a pencil. Well, if they're sitting next to each other, they can share a pencil while we're doing notes and it can work out. If they're not sitting next to each other, they can't share that pencil. It doesn't work, right? So if I have these two students sitting next to each other, one student gives the other a pencil, they can pass it back and forth, and they can take their notes together as long as they have that, as long as they're in close proximity, as long as they are kind of bonded together. Okay? And that's what a covalent bond is. These atoms are sharing electrons, so they can't move away from each other because you can't share something when you're away from them, right? So that's a covalent bond, is sharing electrons. Okay? Water is an example of a covalent bond, and we know water's chemical formula is H2O, two hydrogens to one oxygen. Now, breaking down the parts, chemical formula is a ratio of atoms in the compounds. Breaking down the parts, every capital letter is a new element. So if you see two letters together, you just need to make sure that one of those letters is lowercase. If one of those letters is lowercase, then it's one element. If they're both capital, it's two elements. Also, this 2 is called a subscript, and that goes along with hydrogen. The subscript will always follow the element it's referring to. So when we see H2O, it means two hydrogens, and O, we don't have a subscript. That doesn't mean zero. Just by writing O, it means we have one, right? If we have more than one, then we'll use our subscript. So I said covalent bonds and ionic bonds were our two types of bonds that we're learning about. Ionic bond is the other one here, and that's the main bond that we focus on here. An ionic bond forms between two ions, or atoms with a charge. Doesn't matter if it's positive or negative. Remember, ions are when the charges don't match up, when positives and negatives are not the same. Sodium often will have a positive charge. Chlorine will often have a negative charge. They form an ionic bond. Okay? So we're going to get more into that in a little bit. But sodium and chlorine, they make table salt. Okay? So we have all these positive sodium atoms all sprinkled throughout, and then these negative chlorine atoms all throughout as well. And you can see that they are going to share those electrons. Or not electrons, they don't share. Sorry, that's covalent. Okay? They don't share, but they're attracted to one another because of their opposite charge. Remember, opposites attract in science. We have a positive and a negative next to each other. They want to be next to each other. They're going to be stuck next to each other because positives and negatives are attracted to one another. And that's the basis of an ionic bond. Okay. So now, why do atoms form bonds? Well, it's all about energy. Okay. Okay. When atoms are individual, okay, when we have individual atoms right here, one carbon, 4 hydrogens, that takes a lot of energy for them to exist like that. They don't want to be there. Just like my toddler doesn't want to have a lot of energy, he needs to burn it off. So these guys burn it off, and they become one molecule. When they form those bonds, forming those bonds releases a whole bunch of energy, and it works great. Okay, so forming bonds releases energy. Now, why chemical bonds form? Okay, some elements are super reactive. Reactive means that they readily form chemical bonds. Some elements are more reactive than others. We're going to take a look at that. Here's the idea behind it, is that elements want to be like noble gases. Fluorine has 9 electrons. See, 9 protons, so it has 9 electrons. But 9 electrons is not a full outer shell. It wants to be like a noble gas. noble gases, if we put them on our atom builder board, you'd see that they would have a full outer shell of electrons. Fluorine wants that. Well, it needs to be like neon then, which has 10. So all it needs is one more electron to be like neon. And chlorine needs one more electron to be like argon. So they're going to do anything that they can. They're very reactive, and they really want to get that one electron any way they can to bond to become more like neon. Okay? Lithium, way over here, lithium has 3. Well, it either needs to gain 7 to be like neon's 10, or lithium with 3 can lose 1 and become like neon with 2, right? It's going to be a lot easier to lose 1. Okay, so same with sodium. 11, it can just lose 1 to be like neon that has 10. Okay? And as we move towards the middle, they have to lose or gain more electrons. Okay? Boron and carbon, they have to lose or gain a lot of electrons in order to be more like these noble gases. Okay, so they're less reactive than the ones that are close to it, than the alkali metals and the halogens, the alkaline earth metals and the oxygen group. Okay, so this we're kind of getting into now what we call valence electrons, which are the electrons in the highest unfilled energy level that contribute to bonding. Okay, so most elements want to have 8 of these valence electrons, and I have some pictures here. We're going to show you what these valence electrons are. Don't worry. Okay, most elements want to have 8. Hydrogen and helium, they only want to have 2 valence electrons. Okay, so if we look at this picture here, we have sodium. Okay, and sodium typically has 11 electrons, 2 in the first, 8 in the second, and that leaves 1 left over in the third. That means sodium has 1 valence electron, 1 electron in its outer shell that contributes to bonding. It doesn't want to have that 1, okay, but chlorine has 7. It wants to have 8, right? So sodium can give its electron to chlorine. Chlorine's now full, and now sodium, its outer shell is now the second one, and now it's full. Okay, so both elements are happy, both atoms are happy. Sodium lost an electron, so it lost a negative charge, it became positive. Chlorine gained a negative charge, so it becomes negatively charged, right? And they have a positive and a negative charge. 2 ions, they're going to form that ionic bond. That's how we get that table salt. Okay. So now we're going to take some time. I'll show you guys how to do this, going from left to right across the period. Each new element has 1 more valence electron on it than the one before it. So as we go from left to right, like nitrogen has 5, oxygen has 6, fluorine has 7 valence electrons, neon has 8 valence electrons. Sweet. Okay, we'll get all that, no worries. Okay. These pictures here, these are incorrect, right? Nitrogen with 5, yeah, there's 5 valence electrons. Oxygen with 6, yep, 6 valence electrons. Fluorine with 7, yep, 7. Except then neon has 8, this one shows 1. So incorrect. This one would actually be lithium and not neon. Okay, we're going to write that on the periodic table in a little bit, don't worry. Okay. Now how this works, valence electrons on the periodic table. Well, beryllium, if we look, beryllium has 2 valence electrons. Oxygen has 6. Remember, they want to have 8. So oxygen wants to gain 2 more. Beryllium wants to just lose those 2. That's easier than gaining 6. So beryllium gives its 2 to oxygen. Oxygen takes them, and now beryllium's positive, oxygen's negative. They form a chemical or an ionic bond, and they're paired together. Okay? But they're both happy. That's the biggest thing. Okay? Now carbon and oxygen, I think this is the last slide I have for you. Carbon has 4. That's weird. So what it can do is it takes oxygen has 2. This one, both of these oxygens want 2, right? And carbon has 4. So it pairs with 2 oxygens sharing their electrons together, sharing 2 of carbon's 4 valence electrons, each oxygen does. And now they're all happy except they're sharing. So what kind of bond happens when we're sharing electrons? What type of bond would that be? Sharing electrons is a covalent bond. Transferring, becoming positively or negatively charged, that's an ionic bond. Lewis dot diagram, I don't need to teach you anything about it. this is just an easier way to show the number of valence electrons. Okay, and you'll